trig integrals. We can start with the basic ones we already know. So there's the standard integrals. So sine goes to minus cos, cos goes to sine, sec squared goes to tan. So they're the three very basic ones. But then we said, oh, well, look, tan, we may as well remember it's minus the log of cos or log of sec, whichever you prefer. So, okay, what about if it's to some other power though? Now, I'm only going to look at sine to the power of n because once we know that, we can do the complementary. But if you were doing it from scratch, you basically use exactly the same technique for cosine as you do sine. So let's have a look at sine. Start with the power of 1, standard integral, we know it's minus cos. Power of 2, well, we've seen this now, we'll use our double angle result. So half of 1 minus cos 2x, and we get our answer. Okay, let's go to the next power. Sine cubed. What I do with this one is I rewrite sine cubed as sine times sine squared. The reason for doing that, the sine squared can be changed to 1 minus cos squared, and I now have derivative times a function. So, I mean, if you do a substitution, u is cos x to u is minus sine x. So integral 1 minus u squared, we have our answer. Basically, if it's an odd power, that's what we're going to do every time. You pull out one of the sine x's, it will end up becoming the du. Because what's going to be left will be sine squared to some power. And the sine squared you can always change to 1 minus cos squared. It'll become 1 minus cos squared to some power, but you can do your substitution, u equals cos x. So all odd powers can be handled that way. Okay, let's go up to power of 4. Sine to the power of 4, this time I don't pull a sine out, I leave it as sine squared squared. Then the sine squared, I use my double angle result. So I've got a quarter, because the half squared, but then 1 minus cos 2x squared. Expand it out, and then each one of those we know how to do. The first two are quite easy, but cos squared, I'm going to have to use my double angle result again. So that'll be a half of 1 plus cos 4x. So tidying that all up, and then finally integrating, we get an answer. So when you have an even power, you'll always leave it as sine squared to some power. Then use your double angle result, expand out. Now you might have to apply it again depending on how high the powers are. So hopefully if it's an even power, they don't get too carried away. I'm sure they won't. They'll only be very low powers. We'll keep going. I mean, 5, it's odd, so same technique. We pull out the sine. I've got sine squared squared. The sine squared I can change to 1 minus cos squared. I've now got a simple substitution, which allows me to find the answers. So odd powers, you want odd powers on these, a lot quicker. But what if we've got a mixture of sine to the power and cos to the power? How do we deal with that? Most of the time it's just a simple substitution. Sine x or cos x, depending. So let's have a look at this one. Cos to the power of 5 sine cubed. Have a look at what I've done. The sine cubed I've changed to sine squared times sine. But then the sine squared I've changed to 1 minus cos squared. So by pulling out that single sine, I've got the du. And then everything else can be written in terms of cos. I can then just do the simple u equals cos x from there. And we have our answer. So if both powers are odd, either one can be u, cos or sine, it doesn't matter. But you pull the power of one out, it's going to become your du. So it's probably more sensible to use the higher power as the u, which means the one you're pulling out will be the lower power. Because that means your 1 minus cos squared, in this case, is going to be raised to a lower power, and so there's less expansion to do. Here's one where one is odd and one is even. So if I've got that situation, here's how I rewrite it. You'll notice, because I've got an odd power, I can still do the same thing. I'll pull out one of those powers, so in this case cos x. That would leave me with cos squared, which I could write as 1 minus sine squared. Again, I've now got a simple substitution. So u equals sine x in this case. Sub in, we get our answer. So handled exactly the same way. So always choose your even one to be the u. So the odd one is the one you're going to pull out and use it as the du. That leaves us with both even. I can't pull out the cos x or the sine x now, but I can do that. Because they're even, I can always write one of them as the other one, 1 minus it squared, to the power of something. So that's what I've done here. I've changed the cos squared to 1 minus sine squared. Expand out, and I now just have 2 trig integrals to sort out using whichever technique it is. Now, fortunately, I've done both of these, so I'm going to cheat and just sub the answer in. So that's what we got for sine squared. That's what we got for sine to the power of 4. Tidying it up, there's the answer. And so if they're both even, that's how you do it. And you'll notice I chose the smallest powers I could possibly have there to make life easy for myself. Okay, so both powers are even. You'll end up using sine squared is 1 minus cos squared, or cos squared is 1 minus sine squared, whichever. And again, I'd go for the lower power. Let's have a look at tan. And again, whatever technique I use for tan, I can use for cotan. They're complementary ratios. So tan, well, tan to the power of 1. Now we're just writing down minus the log of cos or log of sec. Tan squared. Tan squared we can handle because tan squared is sec squared minus 1. Integrate that, we have tan x minus x. Tan cubed. What are we going to do with tan cubed? I pull out, it looks like I'm pulling out the tan x, but I'm not. I'm actually pulling out the tan squared, because the tan squared can always be changed to sec squared minus 1, and sec squared is the derivative of tan. So I can now split this into 2 integrals. One can be done with a very simple substitution. The other I'll just handle however we do, because the power is going to be reduced. So tan x sec squared. On the first one I'll do a simple substitution, u equals tan x. The second one we already know the answer to, it's up there. So we end up with, eventually, there it is, half tan squared x plus the log of cos x. Tan to the 4, exactly the same thing. So the nice thing about tan is it's the same technique, whether the power is odd or even. I pull out a tan squared, change it to sec squared minus 1, split it into 2 integrals. The first integral, simple substitution. The second integral is another tan function, but to a lower power. Again, we've already worked out the answer to tan squared before, so I'll just drop it in there. There's the tan x and x. We get our final answer, a third tan cubed minus tan x plus x. Sec is the next interesting one. And once again, cosec will be done exactly the same way. Let's look at sec. Sec to the power of 1. Now this is how you actually get it. It's another one of these ones where in reality just remember the answer. But this is how you get it. I'm sure you would have thought of this method, by the way. You get sec. Well, how do you do it? Of course, you multiply top and bottom by sec plus tan. Why? Well, look, tidy up the top and have a look what you get. The top we've got sec squared, which is the derivative of tan, and then you get sec tan, which is the derivative of sec. So you've actually got a derivative on function now. So it becomes the log of sec plus tan. As I say, it's one of those ones where we'll just remember that the integral of sec is the log of sec plus tan. A lot easier. Sec squared, well, we know that's tan. That one's easy. Here's the one we love. Sec cubed. I could rewrite that as sec x times sec squared. And I'm going to do it by parts. My u is sec x. Do u become sec tan? Do v is sec squared, so v is tan x. So uv minus the integral of v du. Sec tan minus the integral of sec x tan squared x. I'm now going to change my tan squared to be sec squared minus 1 and then break that integral into 2 integrals where I get minus sec cubed plus the integral of sec. Well, the integral of sec we know, that's the log of sec plus tan. Integral of sec cubed, that's what we're trying to find. We now look at this as an equation. I'll move that integral of sec cubed to the left-hand side. I now know 2 times the integral of sec cubed is sec tan plus the log of sec plus tan. Therefore, integral of sec cubed is a half of sec tan plus a half log sec plus tan. That is how you handle odds powers. Have a look what happens with the even power compared to that last one. Sec 4, what do I do? Oh, it's easy. I'll just pull out a sec squared, which can be changed to be 1 plus tan squared. Substitution, u equals tan x. 1 plus u squared, add 1 to the power over the power, bang, you got the answer. So the even powers, you can always factorise it this way. Pull out a sec squared, that's going to become your du. and then you'll be left with sec squared to some power, and that sec squared you change to 1 plus tan squared, and then you can do your substitution, u equals tan x. So yes, evens, much nicer than the odds. All right, 4G, playing with trig integrals.